Okay. Oh. Hey guys, sorry we were having a little bit of trouble with my internet connection. I think Olivia's trying to get in. There we go. Hey Olivia, sorry we're having some internet trouble. Hopefully we will stay pretty stable. I got kicked out several times in my last class, so I think we've got a lot of people zooming here today. So anyway, if anything happens and y'all get bumped off or whatever, then just try to log back in and hopefully we'll be good to go. All right. Okay, I'll get ready and get my screen shared and get us loaded up. All right, so we've been talking about percents for a little bit now, and we have talked about how when we're dealing with a percent, we are comparing a number. We're looking at it represented as per hundred or per hundredth when we talk about the decimal place value, and the two places after the decimal is the hundredths column. And so we've been looking at these different things, the different ways to deal with percents. Drop this down just a little bit. Okay. All righty. All right, so we've been looking at, real quick, I'm going to back up to 47. So talking about percent per hundredth or per hundred. We've talked about how I can change from a percent to a decimal back to a percent. We can change a fraction to a decimal and then change it to a percent. We've been working on all that. Then we looked at lesson 48 was dealing with finding the percent of a number, and we talked about how if I have a whole number and I want to find a percent of that number, then it is represented as a part of that number. And I gave you guys the formula of percent times whole equals part. And so as long as I know two of those pieces of information, I can solve for the third. I just plug the two that I know into my equation or into my formula, and then go ahead and solve. We know that if we start out with a percent, we have to first change it to a decimal, then multiply it by the whole number to find the part. Or if we don't know the whole number, then we will use our properties of equality to solve. Okay, so On 11.9, let's see, we had 2, 3, 5, 8, and 11. So where do you check these? On, okay, so that was from the page before, yeah, so I've got those written in red, so we've checked those. And then we moved on to lesson 49, fraction percent conversions. And this is where we start out with a fraction, we have to convert it to a decimal, and then put it in percent form. Okay, so this is from lesson 49. So let's get ready and check these. All right, so in activities 2, we had the bottom section for homework. So the fraction was given, we had to find the percent. So for 5/6, it will be 83.3 repeating percent. Remember, I told you that whatever the repeating digit is, I want to take it to one place beyond the decimal. If it's a single repeating digit, I will take that one place beyond, draw my repeating symbol above it, and then put the percent sign. That was for 5/6. For 5/8, I have 62.5%. For 9/10, that will just be 90%. And 7/8 will be 87.5%. Okay. Then over on the right-hand column, I'm going from the percent to a fraction. So with 30%, I would start out with that as 30 over 100, and then I would reduce to 3/10. With 80%, I would put that as 80 over 100, and then when I reduce it, it becomes 4/5. 70 over 100 would be what I would set up for 70%, so that's going to be 7 over 10 reduced. And then 37.5%, I would put that as 37 over, 37.5 over 100, and then that reduces to 3/8. Okay, any questions on any of those? Awesome. Then we moved on and we looked at activities 5. We're doing what percent, or what percent of a whole number. So we're doing percent times whole equals part. So activities 5, I'll go down the first column first. So on the first one, x is equal to 40.5. Below that, x is equal to 30. Underneath that, x is equal to 20%. Okay. Middle column, x is equal to 2.88. The middle one, x is equal to 4,000. And then the last one in the middle, x is equal to 300%. And then the last column, x is equal to 178.5. In the middle, x is equal to 300. And then the last one, x is equal to 0.3%. Any of those that you would like me to go over? Any of those that you missed and we need to work through? Okay. All right, then lesson 50, we talked about the percent decrease, and we talked about how I have the formula to where I take my original amount and I subtract the new amount, and then I divide by the original amount, and that gives me a percent decrease. All right, our homework in this section was activities 4, fractions, decimals, and percent. So activities 4, let's go ahead and check these. Okay, so we have 1/3 is equal to 0.3 repeating, which ends up being 33.3 repeating percent. The next one is 0.125, which is 1/8, and then that ends up being 12.5%. Then they gave us 40%, and that is equal to 2/5. So that would be 0.4 as my decimal. And then 1/2 is going to be 0.5, which is equal to 50%. Now on the right-hand side, 0.75 is going to be 3/4. So that would be 75%. And then we have, they gave us 66.6 repeating, so that's equal to 2/3, which is equal to 0.6 repeating. 7/8 is equal to 0.875, which ends up being 87.5%. And then 0.6 is 3/5, and that would be 60%. Any questions on that? Awesome. And then we're holding this section. We're going to go back to it later. All right, so today we're going to start with lesson 51. So lesson 51 on page 113, talking about discounts and sale prices. And I don't know about you guys, but whenever I go shopping, my kids always laugh about whenever we're going to get something, and they always ask if I have a coupon because I'm always looking for a coupon. I'm always looking for a sale. I'm always looking because I want to be able to buy the things that we want, but then I want to be able to see if we can stretch that money a little bit further and get, maybe more than what I'm looking for, especially like with the holidays coming up and thinking about Christmas shopping, or maybe if you ever get birthday money or you get money at Christmas or stuff like that. Whenever you're getting ready to spend that money, sometimes if we look for a sale, we're able to make that money go a little bit further. And so understanding discounts and sale prices is a very real world thing that we can deal with a lot to help us to save money. And so understanding this formula is going to be something that'll be helpful to you, if not now, but at least in the future. So it says discounts and sale prices are calculated as a percent decrease. So these are percent decreases from the original price. So it says, remember, our percent decrease formula is the original price minus the new price divided by the original price. So it says solving for the new price, we get this formula, okay, where our new price is our original minus, where I multiply the original times the percent decrease. So let's say something, and so think about this for just a minute. When I think about the original price, okay, the original price is like paying 100% of something. If I went to buy, I don't know, if I went to buy a pair of shoes and they were $50, then if I paid $50 for them, I've paid 100% of the price, okay? So basically when I'm looking at this, the next formula that they're looking at, when I've got the 1 minus the percent decrease, that's like saying if they were on sale for 20% off, then that means I would be paying 80% of the actual price. So that's what they're talking about right here when I have the new price is equal to the original price times 1 minus the percent decrease. So my example here would be like if they were on sale for 20% off, then this is like saying 100% minus 20% equals 80%. Okay, so that's kind of the example of what we're looking at. So that means I would multiply my original price times 80% because that's what I'm actually going to pay. Now, if I wanted to find out what the discount was, then I would multiply my original price times the 20% discount. And that would tell me how much money I'm going to save. But if I want to calculate the new price, then I've got to multiply by the amount that I'm actually going to pay. Does that make sense? So we can look at it two different ways. I can look at it and calculate my amount saved, or I can go ahead and calculate how much I'm going to spend, okay? So it says to find the discounted price or the sale price, change the percent discount to a decimal and subtract from 1. Multiply this number by the original price to get the discounted price. When working with money problems, round all answers to the nearest cent or to the nearest hundred, okay? So the example they've given us is Denny has marked all clearance items 75% off. if the original price is $9.95, what is the discounted price? So you can see where it says let X equal the discounted price. So that's where we've plugged in. So we have X. We have our original price. And what I'm going to do is I'm going to go ahead and write this formula real quick where we have if I'm finding discounted price is equal to the original times 1 minus percent discount. That's the formula that I'm putting in. So $9.95 is my original. 1 is my, like saying 100% minus 75% or minus 0.75. So basically this would be the same. So this is like saying 100% minus 75%, but they've changed it to decimals, okay? So we can calculate, since we can't multiply by percents, we have to change them to decimals. So that's why when it says 0.25 over here, it's because I'm paying 25%, or I'm going to pay 25% of the original cost. So $9.95 times 0.25 ends up being 2.4875. Like I said, we're going to round to the nearest hundredth place. The hundredth places is 2 places past the decimal. So this is when I look at his neighbor and I say, okay, I have a neighbor of a 7. My rule is that if it is 5 or up, I round up. If it's 4 or below, I keep that digit the same. So I know that my 8 will need to round to a 9. So my new price is $2.49. All right, so we're going to practice with that. And it says if the original price of an item was $5.99, find the sale price for the following discounts. Okay, so we want to find the sale price if my original was $5.99. So I'm going to start out where I have X is equal to $5.99 times 1 minus what? Okay, so it's not going to be, we're looking, if 10% is my discount, how much am I actually going to pay?
60% of the entire thing.
How much?
You're going to, oh, no, sorry, the wrong thing. You're going to be paying 90% of the entire thing.
Yeah, we're going to pay 90% of the whole thing. So good. So we have X equals $5.99 times 90. And we know that that means when I change 90% to a decimal, that would be times 0.9. Okay, so I've got $5.99 times 0.9. Remember when I multiply, I don't worry about my decimals while I'm multiplying. I put my decimals in at the end. So 9 times 9 is 81. Put down my 1, carry my 8. 9 times 9 is 81. Plus the 8 that I carried is going to be 89. Put down my 9, carry my 8. And 5 times 9 is 45. And 45 plus 8 is going to be 53. Is that right? Now, when I look at this, I count my places after the decimal. And in my first number, I've got 2 places after the decimal, and then I have 1 place after the decimal by the number I'm multiplying by. So that is a total of 3. So I start at the end and I go over 1, 2, 3 places, and that tells me where to put my decimal. So now I've got X is equal to 5.391. Put dollar signs in there. So now my 9 is in my hundredths place. I look to his neighbor, it is a 1. That tells me I'm going to keep my digit the same. So X is equal to $5.39. Any questions on that? We set up our equation using the sample that they gave us, where I'm going to set it up and I have my, I set up my equation like they showed me to where I take 1 minus the percent discount to show the total percent that I'll be paying. We changed our percent to a decimal and multiplied, then rounded to our hundredths place. All right, doing the same thing, but now we're looking at a 25% discount. So I'm going to start with x is equal to $5.99 times 1 minus 25%. So x is equal to $5.99 times what percent?
75.
75%. And what is 75% as a decimal?
0.75.
0.75. Good. So now we're going to multiply $5.99 times 0.75. 9 times 5 is 45. Put down my 5, carry my 4. 9 times 5 is 45 plus 4 is 49. Put down my 9, carry my 4. 5 times 5 is 25. 25 plus 4 is 29. Placeholder 0. 9 times 7 is 63. Put down my 3, carry my 6. 9 times 7 is 63. Add my 6, so that's 69. Put down my 9, carry my 6. 5 times 7 is 35, and 35 plus 6 is 41. 5 plus 0 is 5. 9 plus 3 is 12. Put down my 2, carry my 1. 9 plus 1 is 10, plus 9 is 19. Put down my 9, carry my 1. 1 plus 2 is 3, plus 1 is 4, and 4 plus nothing is 4. Now I've got to look at how many places after the decimal I have, and I've got 1, 2, 3, 4. So that means I start at the end and move my decimal 4 places to the left. 1, 2, 3, 4. So now I can see that x is equal to $4 and then 4925. Look to my hundredths place. Look at his neighbor, it is a 2, so I'm going to round where x is equal to $4.49. Any questions on that? All right, our last one is a 60% discount. So x is equal to $5.99 times 1 minus 60%. So what percent are we going to be paying? 40%. What is that as a decimal? 0.4. So $5.99 times 0.4. 9 times 4 is 36. Put down my 6, carry my 3. 9 times 4 is 36, plus 3 is 39. Put down my 9, carry my 3. 5 times 4 is 20, plus 3 is 23. Looking at my decimal places, I have 1, 2, 3 places. So I go 1, 2, 3 places to the left. So x is equal to 2.396. I need to round to my hundredths place. I look at his neighbor, it is a 6. So that tells me I've got to round up. So x is equal to $2.40. Okay, because the 6 tells me I need to round that 9 up, 9 has to round to 10, which means that 1 carries over to the 3 and becomes a 4. Any questions on how to calculate the discounts? All righty. Let's look at activities 2. It says Denny sells 5 different staplers with the prices of $7.29, $8.79, $10.29, $12.99, and $14.99. Denny gives all teachers and homeschoolers a 10% discount. What is the discounted price of each stapler for teachers and homeschoolers? So let's look at that for a minute. I've got each of these prices, okay? So think about a 10% discount what is the percent that I'll be paying for each of them? If it's 10% off, how much will I pay? What percent? 100% minus 10% is going to be what? 90%. Good. So I'm going to start out with 729 times 90%, or actually we'll just go ahead and put it as 0.9. And then the next one would be $8.79 times 0.9. Then we'd have 1029 times 0.9. Then we would have 12.99 times 0.9 and 14.99 times 0.9. So we've set each of those up for you to be able to solve, and that will be your first part of homework. We'll be solving those. Okay, so this will be activities 2. Today is 11, 16, 20. So we've already written the equations for what you'll need to solve, but find the discounted price for the staplers. Now it says if Denny has a special sale and offers all staplers for $7 each, what is the percent discount for each stapler? Okay, so let's look at this one. If he says that, hey, I'm just going to have them for $7 each. Now what I've got to look at is, first of all, I'm going to have the first stapler with $7.29. Okay. My new price is $7. My original was $7.29. So I have set up using my equation of original minus new. Let me write that somewhere else. I can't see that real well. I'll write it down here at the bottom. Original minus new divided by original equals percent discount. Okay, so we're going to set each of these up. We'll do a couple of them together, and then the rest of them will be for homework. So 729 minus 7 divided by 729. Then I will have 879 minus 7 divided by 879. Then we will have 1029 minus 7 divided by 1029. Go down here to have some space. Then 1299 minus 7 divided by 1299. And then 1499 minus 7 divided by 1499. Let's do the first one and the last one. All right. What is 729 minus 7? It's just going to be 0.29, right? So I've got 0.29 over 7.29. So now I'm going to divide that. Now this is where we've got to think closely about dividing with decimals, okay? So this means I divide my bottom number into my top number. So I've got 7.29 into 0.29. Remember that when I'm dividing decimals, I cannot, if my number on the outside has a decimal, I've got to move it and make that number a whole number. So to be able to make 7.29 a whole number, I have got to move that decimal 2 places to the right. If I move that one 2 places to the right, I have to move my one underneath the division sign 2 places to the right. So now 0.29 has become 29. I'm gonna go ahead and put that decimal in my answer so I don't forget it. But 729 still won't go into 29. So I add a 0. It still will not go in, and I'm going to go ahead. So we said it won't go into 29. 729 will not go into 290. So I'm going to add another 0 and think about how many times will 729 go into 2,900. So when I'm dividing big numbers like this, a lot of times what I'll do is I'm going to start with that first digit and think about 7 times what will be close to 29. So 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, I'm close. 7 times 4 is 28. So then I think about, okay, well, if I multiplied by 8, when I multiply 8 times 9 is 72, put down my 9, carry. Actually, let's just go ahead and try it. Let's say I wanted to try 8. 8 times 9 is 72, put down my 2, carry my 7. 8 times 2 is 16, and 16 plus 7 is 23. So I put down my 3, carry my 2. 7 times, well, why did I even say 8? I was doing 4, thinking 28. So obviously we could see that was way too much. So, well, didn't mean for my eraser to be that big. Let me make that smaller. We saw that was way too big. I meant to do a 4. I don't know why I did an 8. Try 4. 4 times 9 is 36. Put down my 6, carry my 3. 4 times 2 is 8. 8 plus 3 is 11. Carry my 1. And 4 times 7 is 28 plus 1 is 29. And I can see that it is just barely too much. But 4 times 729 is going to give me 2,916. So that is too much. So I'm going to go back and make that a 3. All right, 3. 3 times 9 is 27. Put down my 7, carry my 2. 3 times 2 is 6, plus the 2 that I carried is 8. And 3 times 7 is 21. Now I subtract. And so I've got 10. That's going to become a 9 because I have to borrow, and that 9 becomes an 8. So 10 minus 7 is 3. 9 minus 8 is 1. 8 minus 1 is 7. And 2 minus 2 is nothing. I'm going to add another 0 and bring it down. So now I've got 729 will go into 7,130 how many times? Well, think about 729 and 7,130. That's going to be super close to being multiplied by 10. So let's try a 9. 9 times 9 is 81. Put down my 1, carry my 8. 9 times 2 is 18, plus 8 will be 26. Put down my 6, carry my 2. 9 times 7 is 63, and 63 plus 2 is 65. So now I'm going to subtract. I cannot do 10, 0 minus 1, so that has to become a 10. I had to borrow from my 2 right there. So 10 minus 1 is 9. Now I have 2 minus 6 I can't do, so I have to borrow from my 1. That becomes a 0, and now I've got 12. 12 minus 6 is 6. I can't do 0 minus 5, so I have to borrow from my 6. It becomes a 7, and that becomes a 10, and 10 minus 5 is 5. Add another 0. Bring it on down. So now I'm trying to look at what's going to be after, or what I'm going to do now. 729 will go into 5,690. Well, we know 9 times gave us 6561. So again, this is where I'm looking at my 7 and my first 2 digits, which is 56. I know 7 times 8 is 56, but because I've got the 29 that I've got to multiply by also, I know 8 is going to be too much. So I'm going to try a 7, because 7 times 7 is 49. Put my 7 there. 7 times 9 is 63. Put down my 3, carry my 6. 7 times 2 is 14, plus the 6 I carried is 20. Put down my 0, carry my 2. 7 times 7 is 49, plus 2 is 51. Subtract. 10, 9 becomes an 8. 10 minus 3 is 7. 8 minus 0 is 8. 6 minus 1 is 5. So now, because I can see where if I move my decimal 2 places to the right, because remember, I don't have to keep going. All right, as long as I've got places that I can move my decimal to make it a percent, but then also I've got this neighbor guy to look to see what I can round that 9 to. So when I'm rounding here, I've got 3.97. So I want to go ahead and use that to round my 9 up. So that's going to actually be 4.0 or 4%. Okay. So it took a while to divide. Now, how about this? You can use a calculator for these. Okay. So I'm going to make a note. Can use calculator. Okay. So to do the division with your decimals, I am totally fine with using a calculator. So now let's go ahead and do that. And I'm going to show you guys. So again, here, I start out with $14.99 minus 7 over $14.99. So $14.99 minus 7 is going to leave me with $7.99 divided by $14.99. All right, so I'm doing $7.99 divided by $14.99. Where is my calculator? You know what? I think, oh my, maybe not. I think my kids deleted my calculator. Let's see how long it'll take to get one. One of those things where if I can remember the Apple ID, if it asks me. Yay. I never know if I'm actually going to remember what the. Okay. So now. Of course, now it'll take forever to load, I guess. Okay. So I know that more than likely y'all have used a calculator before, but I just wanted to make sure that when we are working to divide, remember we divide the numerator by the denominator. So we started out with our problem. We had $14.99 minus 7 divided by $14.99. We subtracted and said that $14.99 minus 7 would be $7.99 in my numerator. And then I'm going to divide by $14.99. Okay, so we can see that we've got a pretty big number here. So what I'm going to do is when I look at that, I've got 0.53302. What I'm going to do is I want to look at that and see if I move my decimal 2 places to the right, then I'm going to be at 53.3%. Okay. And so I want to look at the neighbor next to that second 3 to make sure that I don't need to round it up. It is a 0, so I'm going to keep it the same. So on that one, it will be 53.3%. If I can get back to my page. So we found out it would be 53.3%. Okay. So for homework, you're going to do activities 2. You can use a calculator on this section. We've already set up our problems for the first part where we're looking at if it's a 10% discount, how much would they cost? And then we've set each part up for if it's a if it just makes them a $7 flat price, what is the percent discount for each? So, did I not write? Okay, I didn't write it up here for my answer. So we said this one was 4%. Okay, so you can see that the first one is only a 4% discount. The last one is a 53.3% discount. Okay, so that's what we're going to do in our homework on this section. There is the bell for the break. So we'll go ahead and take a break and come back. It's always so quiet when nobody's here. All righty. All right, so let's go ahead and work together through a little bit. I'm going to erase so I can have some room to see. Okay, let's look at activities 3. Okay, make sure you're following along with these as I'm working through. Let me share my screen. Because doing this as practice, I want to make sure that you get the benefit of it. So make sure that you're doing these with me in your book. Math is one of those kind of participation sports where if you're not doing it with me and you're just watching me do it, then it's going to be more difficult when it comes time for you to do it. So let's keep practicing, working with our order of operations here. All right, so it says, remember to multiply each term by the denominator to eliminate fractions. So that's going to be in the second row. So we're going to look at that. All right, so the first one, remember when we talked about order of operations and we talked about PEMDAS? Parentheses, exponents, multiplication and division. If both are in the same one, do it from left to right. Addition and subtraction, same thing. If they're both in the problem, do it from left to right. So we know that parentheses is our first step. Excuse me. Now notice I have x minus 2 in parentheses. There's nothing I can do there because I do not know what x is. So what I'm going to have to start with in this problem is using the distributive property. And I'm going to have to distribute my 3 to x and 3 to negative 2. So 3 times x is 3x. 3 times negative 2 is negative 6. So now I have 3x minus 6 plus 7 equals 5 plus 12 divided by 3 minus x. Okay? Do this along with us now. So now 3x minus 6 plus 7 equals 5 plus 12 divided by 3 minus x. According to the order of operations, what am I going to need to do first? What am I going to have to do first? Divide. I'm going to have to divide 12 divided by 3. Order of operations tells me that division comes first. What is 12 divided by 3? 4. 4, okay? I'm going to go ahead and put my 4 there. Notice it is a plus sign in front of it. And so it will be a positive 4. So I know that when I go, I'm going to have plus 3. So I have 3x minus 6 plus 7 equals 5 plus 4 minus x. Okay. So now I'm going to combine like terms on each side. So on the left-hand side, I'm going to combine negative 6 plus 7. And on the right-hand side, I want to combine 5 plus 4. So what is negative 6 plus 7? Remember, when I have opposite signs, I find the difference and keep the sign of the larger. So what is the difference of 6 and 7? What is 7 minus 6? 1. And what is the sign of the larger term? Positive or negative? Positive, so it will be plus 1, okay? So I've got 3x plus 1 equals, what is 5 plus 4? 9 minus x, okay? Remember, I like to get all of my variables to the left-hand side. So what am I going to do with that minus x on the right-hand side?
Add it on each side.
I'm going to add it on each side. Good, because I want to be able to move it. And remember, my properties of equality says whatever I do on one side, I have to do to the other. So to be able to move x, I'm going to add it. Because it is being subtracted, to undo it, I add. So 3x plus x is 4x plus 1 equals 9. What needs to move from the left-hand side to the right-hand side?
1.
1. It is positive, so I move it by subtracting from both sides. So 4x is equal to 8. Now, when I have 4x side by side, what operation do I understand that to be? Multiplication. How do I undo multiplication? Division. So I have to divide by 4, so x is equal to 2. Okay? So we had several things that we had to do before we could actually start solving for x. We had to distribute the 3. We had to look and use our order of operations to tell what we would do first to be able to look and do that division before we started working the problem. All right, we are going to do one more, and then the one in the middle will be for homework. So let's do the one on the end. Notice I've got 2 things here I've got to distribute. So I'm going to start out with that 4 times 2 minus x, and then I've got that negative 3 times 1 times negative x. All right, so what is 4 times 2? 8. 4 times negative x. I have a positive times a negative, so it will be negative, and 4 times x is 4x. I can't combine it. They stay separate, a number and a variable, because they're different terms, but 4 times negative x will be negative 4x. All right, now notice I'm going to call this negative 3 because it has the minus sign in front of it. So negative 3 times a positive 1. A negative times a positive is a negative, and 3 times 1 is 3. Okay, now negative 3 times negative x. A negative times a negative is a positive, and 3 times x is 3x. So remember, we've got to be super careful about our signs. We've got to think about our rules for adding and subtracting, multiplying and dividing negatives. Okay, and on the right hand side, I just have x minus 3. So now on the left hand side, I need to combine like terms. So I've got a negative 4x plus 3x. What is negative 4x plus 3x? Find the difference, take the sign of the larger. So what is negative 4 plus 3?
Negative 1.
Negative 1. So that's like having negative 1x. We can also just call it negative x. Now I also have 8 minus 3. And what is 8 minus 3? 5. It's a positive 5, so I'm going to have plus 5 equals x minus 3. Okay, is everybody good with how we combined our terms? Okay, so now I have negative 1x plus 5 equals x minus 3. Remember, the x on the right-hand side is the same as 1x. So how am I going to move it from the right-hand side to the left-hand side? I'm going to subtract it. It is positive. So to move it, I have to subtract. So now I have negative 1x minus x. Remember, I said that's the same as a negative 1x. So what's a negative 1 minus 1? I owe Mom $1. I just borrowed another $1. So now I owe how much? $2. So a negative, we'll go ahead and put the ones there so you can see them. So a negative 1 minus 1 is a negative 2x plus 5 equals negative 3. Now, what needs to move from the left-hand side to the right-hand side? 5. How am I going to move it? I'm going to subtract it because it's positive. I move it by subtracting. So now I have negative 2x equals negative 3 minus 5. Think about whether you have to picture your number line. Think about it as I owe mom $3, I'm borrowing 5 more, whatever you need to think of. But a negative minus something gives me a bigger negative. Okay, so a negative minus a negative or minus something is going to give me a negative. So I keep my signs and I add them together. So 3 and 5 is 8. So that'll be negative 8. Now I have negative 2x equals negative 8. What operation is happening with negative 2 and x? Multiplication. So to undo it, I need to divide by negative 2. If I divide the left side, I have to divide the right side. So x is equal to a negative divided by a negative is a negative divided by a negative.
Positive.
Positive, good. If I divide or multiply by the same signs, it will be a positive answer. And 8 divided by 2 is 4. Okay, so several steps to work through. Take your time, think through your process, think through order of operations, think through what it takes to be able to solve for x, okay, by using your properties. All right, now the next section on this is going to be clearing fractions first. And it said in the notes, remember, you multiply the term by the denominator to eliminate fractions. So let's look at this first one. What is my denominator? 3. So that means I need to multiply my entire problem by 3. Okay. So I'm multiplying 3 times 2x over 3, multiplying 3 times 1, and then 3 times negative 5. Now notice if I have 3 over 1 times 2x over 3, okay? I can cancel those 3's right there, so all I'm left with is 2x. So when I'm multiplying a fraction by the denominator, all I'm going to have left is the numerator, okay? So 3 times 2x over 3 is going to give me 2x. 3 times 1 is 3 equals negative 5 times 3. A negative times a positive is a negative, and 5 times 3 is 15. So now I have 2x plus 3 equals negative 15. I need to move the 3 on the left-hand side. It is positive, so I move it by subtracting. So now I have 2x is equal to negative 15 minus 3. We just talked about if I have a negative minus something, my answer will be negative. This will be the same as starting out at negative 15 on the number line and moving to the left 3 places. So that would be negative 18. 2 and x are being multiplied, so to undo, I divide by 2. So x is equal to negative 18 divided by 2. I have a negative divided by a positive, which will be a negative because they're opposite signs, and 18 divided by 2 is 9. Any questions on how we did that? The first thing I had to do was to multiply by the denominator to eliminate my fraction. Once I've done that, I just use my properties of equality to be able to solve for x. So let's do one more of these. Let's do the last one. All right, what is my denominator?
2.
2. So I'm going to multiply everything by 2. Remember what we just said a minute ago, that when I multiply by the fraction, it eliminates the denominator and all I'm left with is the numerator. So in my numerator, I'm left with x plus 1 because those 2's cancel each other out. So I'm left with x plus 1 minus 5. Oh, nope, not minus 5. I forgot to multiply. X minus 1. Now I have 2 times negative 5 will be negative 10 equals 2 times 2x is going to be what?
4.
4x. Negative 3 times 2 will be negative -6. So now I have x plus 1 minus 10 equals 4x minus 6. I want all my x values to be on the left-hand side, so I'm going to subtract 4x from each side. So now I've got like x minus 4x, so that's basically 1 minus 4 is going to be negative 3x plus 1 minus 10 equals negative 6. I should have combined my like terms to begin with. Let's do that real quick. So I end up with negative 3x. I've got plus 1 minus 10. What's that going to be? Opposite signs. Find the difference. Take the sign of the larger. So plus 1 minus 10 will give me minus 9. Okay. So now I have negative 3x minus 9 equals negative 6. What is on the left-hand side that needs to move to the right? Negative 9, so I'm going to move it by adding. Negative 3x is equal to negative 6 plus 9. Take the sign of the larger and keep the difference, so that's going to be a positive 3. On the left-hand side, I have negative 3x. Those are being multiplied, so I need to undo by dividing by negative 3. So x is equal to positive divided by negative is a negative, and 3 divided by 3 is 1. So for homework, I want you to do those middle two problems. Okay, so activities 3, the middle two problems. Okay. Now let's review multiplying. Remember that before I multiply, I always want to look and see, is there anything I can simplify first? Is there anything in the numerator that will cancel or simplify with anything in the denominator? So my first number 7, I'm looking to see if it will simplify with 10 or 11. It will not. So now look at 4. 4 will simplify with 10. What are they both divisible by? 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So now I can multiply. 7 times 2 is 14, and 5 times 11 is 55. Same thing with 5/12 times 18 over 25. I start with 5. Can I cancel with 12 or 25? I can cancel with 25. They are both divisible by 5. So 5 divided by 5 is 1. 25 divided by 5 is 5. Now I have 18 and 12. What are they both divisible by? 2. 18 divided by 2 is 9. 12 divided by 2 is 6. So now I have 1 times 9 is 9, and 6 times 5 is 30. If I simplify on the front end, then I know that when I write my answer, it's going to be in simplest form. There's not going to be anything I have to do. All right, 13 over 21 times 4.
Wait.
Oh.
That can be simplified.
It can be. Why? What did I forget to simplify even further?
The 12 and the 18, because 12 and 18 are both divisible by 6.
Yes,
So
12 and 18 are
give
divisible by 6. So that ends up making this a 3, and 6 becomes a 2. So now what do we have?
10 over 3.
10 over, let's see, 3 over 10. 1 times 3 is 3. 2 times 5 is 10. All right, so now we've got to make sure that we're simplifying as far as we can go. So let's look at 13 over 21 times 14 over 19. Well, I know that 13 is a prime factor. So unless I'm dealing with a multiple of 13, what about 14 and 21? What are they both divisible by? 7. 14 divided by 7 is 3, not 3, 2. And 21 divided by 7 is 3. Is there anything else I can reduce? Nope. 13 times 2 is going to be 26. And 19 times 3 will be, that'll be a 7, carry my 2. And so that will be 57. All right, the next one, 3 over 25 times 5 over 18. What will 3 cancel with? 3 and 18. What's 3 divided by 3? 1. 18 divided by 3 is 6. And then 5 and 25. 5 divided by 5 is 1. 25 divided by 5 is 5. So 1 times 1 is 1, and 5 times 6 is 30. Now, what is my rule about multiplying mixed numbers? What do I have to do?
Turn them into improper fractions.
Change them to improper fractions. So 3 and 4/7. Remember, I multiply my denominator times my whole number. So 7 times 3 is 21, and then I add 21 plus 4 is 25. Keep my denominator. So I have 25 over 7 times 3 over 5. Again, I look to see what can I cancel. 25 and 5 are both divisible by 5. So those cancel. So 5 times 3 is 15. 7 times 1 is 7. Typically, if I start out with an improper fraction problem, let's see, does the directions say? No, it doesn't say to, so it does. Typically, if I start out with a problem with mixed numbers and I can write my answer in a mixed number, I'll do that. If it starts out as an improper fraction, I can leave it as an improper fraction, simplest form. So I'm going to go ahead and convert 15 over 7 to a mixed number. How many times will 7 go into 15? 2 times. So basically, I'm just doing 7 into 15. We said that'll go 2 times. 2 times 7 is 14. 15 minus 14 is 1. So my whole number is 2. My numerator is 1, and I keep the denominator the same. So 2 and 1/7. Let's go ahead and look at 3 and 3/8. Multiply 8 times 3 is 24. 24 plus 3 is 27 over 8 times 4 over 9. What can 27 and 9 both be reduced by? 3. 27 divided by 3, is 9. And 9 divided by 3 is 3. What else could they be reduced by?
4 and 8.
4 and 8 can. 4 divided by 4 is 1. 8 divided by 4 is 2. Is there anything else that can be reduced here? The 9 and the 3. Good. 3 divided by 3 is 1. 9 divided by 3 is 3. So 3 times 1 is 3, and 2 times 1 is 2, and that would end up becoming 1 1/2. All right, now we have 2 mixed numbers we have to change. 7 times 5 is 35, and 35 plus 4 is 39 over 7 times 3 times 2 is 6, and 6 plus 1 is 7 over 3. All right, 39 and 3, what are they both divisible by? Both divisible by 3. 3 will go into 39. 3 will go into 3 one time, and 3 will go into 9 3 times. So 39 divided by 3 is 13. 3 divided by 3 is 1. Then my 7's cancel. So 13 times 1 is 13 over 1, which can be simplified to just the whole number 13. And then the last one, 8 times 4 is 32, plus 3 is 35 over 8. 7 times 3 is 21, plus 3 is 24 over 7. What will cancel here? 35 and 7, they are both divisible by 7. So 35 divided by 7 is 5. 7 divided by 7 is 1. What about 24 and 8?
2.
Anything more than 2?
4.
4. Anything more than 4?
8.
8. Good. 8 divided by 8 is 1. 24 divided by 8 is 3. 8 times 3 is 24. So 5 times 3 is 15, and 1 times 1 is 1. So that becomes our whole number 15. Okay, so practicing with multiplying fractions. All right, And then lesson 52 on page 115, we are talking about percent increase. All right, so we've talked about percent decrease. We've talked about how a percent decrease is where we look at the original price, we subtract the new price, and then divide by the original price. With percent increase, this one's flip-flopped. So it's the kind of thing where basically a lot of times stores, maybe there's been what you call inflation, maybe the price of goods are going up, therefore they have to raise their prices on things. And so when we talk about a price increase, we're gonna be similar in that we're setting up a formula or setting up an equation, but this time we start with our new amount, we subtract the old amount, but we still divide by the old amount or the original amount, okay? So percent decrease is original minus new divided by original. Now we're doing new minus original divided by original. So it says one of Denny's suppliers is raising the suggested retail prices of their products at the beginning of next year. The suggested retail price is $9.95 this year and will be raised to $10.45 next year. What is the percent increase in round to the nearest tenth? So remember, on this one, we're saying new minus original divided by original. So that's what they did. They said the new price is $10.45. The original price is $9.95. So $10.45 minus $9.95. And then the original was $9.95. So $10.45 minus $9.95 is 50 cents. And then 50 cents divided by $9.95 is going to be 5% increase, okay? Plug in the numbers that you know, solve for what you don't know. Classwork says a church had 70 children enrolled in its Bible club at the beginning of the year. At the end of the year, there were 84 children enrolled. What was the percent increase in enrollment? So remember, we take new minus original divided by original. So what is my new number of children?
84.
84. What was my original number? 70. So 84 minus 70 over, what number is going to go in the denominator? 70, because that's my original number. So what is 84 minus 70? 14 divided by 70. Okay, so now I have 14 divided by 70. So 70 will go into 14. It will not, so I've got to put a decimal and add a 0. So 70 will not go into 14, but 70 will go into 140. How many times? How many times will 7 go into 14? 2. So 70 will go into 140 2 times. 2 times 70 is 140. So now I've got that is 0.2. Now my question asks me percent increase. I have found a decimal. How do I change a decimal to a percent?
Move it to the right 2 times.
Move it to the right 2 places and add my percent sign. So that means I have to add a 0 and put my percent. So that is 20%. Okay. So we solved and found a decimal, but we had to convert our decimal to a percent. So let's go ahead and look at number 2. Activities 2. It says to round answers to the nearest tenth when necessary. In preparation for the upcoming school year, Denny ordered 50 of each grade of 50 each of grade books and lesson plan books. If he had 6 grade books and 8 lesson plan books before he placed his order, what is the percent increase Denny will have in inventory of grade books and lesson plan books when his order arrives? Assumes no other grade books or lesson plan books were sold. Okay. So let's we're looking at grade books and lesson plan books. So I'm going to start with grade books. I'm going to label it so I don't get them mixed up. And then lesson. Okay, so I'm looking at grade books and lesson books. Remember, my equation is new minus original divided by original. So how many grade books did he have to begin with?
6.
He had 6 to begin with. How many did he order?
50.
50. So how many does he have in all?
56.
Good. How many lesson books did he start with?
8.
8 lesson books. How many did he order?
50.
50. So now he has 58 in all. So now to figure out my percents, what was my, and thinking about, I've got new minus original divided by original. What is my new amount of grade books?
56.
56. What was my original amount?
6.
So I have 56 minus 6 over, what number goes in the denominator? 6, because that was the original amount. So 56 minus 6 divided by 6. What is 56 minus 6? 50 divided by 6. So I can see I've got an improper fraction. So 6 will go into 50 how many times?
8.
Okay, 8. 8 times 6 is 48. I'm going to subtract. 50 minus 48 is 2. I'm going to add a decimal and a 0 and bring my 0 down. And 6 will go into 20 3 times. 3 times 6 is 18. Subtract. I've got a 2. I can keep on adding zeros, but what do I notice is happening here? My 3 is repeating. Okay, so now, what am I going to have to change my decimal to?
A percent.
A percent. What am I going to do to change my decimal to a percent? I've got to move 2 places to the right. But think about what I've got to do when I have a repeating number. Okay, so think I'm going to go ahead and add another 3 there. So I'm going to have 833.3 repeating percent. I always want to go 1 place past the decimal to be my repeating part. So I've got an 833.3 repeating percent increase in my grade books. Let's look at lesson books. Lesson books, what was our new amount?
58.
Okay, new is 58 minus our original, which was 8, and then divide by the original, which is 8. So 58 minus 8 is 50 divided by 8. So again, I'm doing 8 into 50. How many times will 8 go into 50? 6 times. 6 times 8 is 48. Subtract, and I've got a 2. Add a decimal and a 0, put a decimal in my answer, bring down my 0. 8 will go into 20. How many times?
Twice.
Twice. 2 times 8 is 16. Subtract. I've got a 4, add a 0, bring it down, and 8 will go into 40. How many times? 5 times, and 8 times 5 is 40. So I have no remainder. So now I have 6.25. I've got to change it to a percent, so I move my decimal 2 places to the right. So now I know that that equals 625% increase. Okay. So I'm going to erase this work here so I can look at the next problem. All right, so now he's talking about having his customer appreciation day. And so it says that He usually averages 150 customers per day in his store. On Special Customer Appreciation Day, there were 250 customers. What was the percent increase? So remember, we have new minus original divided by original. What was the new amount? 250. What is the original amount? 150. So I have 250 minus 150 over 150, the original amount. 250 minus 150 is 100 over 150. So now I've got to divide 150 into 100. It will not go, so I put my decimal and a 0, put my decimal in my answer. So 150 will go into 1,000 how many times? Obviously 9 or 10 times 150 would be 1,500. I know that 9's probably still going to be a bit much. 8, 7, let's just try 6. 6 times 0 is 6. 6 times 5 is 30. Put down my 0, carry my 3. 6 times 1 is 6, plus 3 is 9. Subtract, and I've got 100. I know that 6 worked because my remainder is less than the number I'm dividing by. Add a 0, bring it down into 1,000. What can I see is going to be happening here? A repeating decimal. So I know, remember that I'm going to go ahead and just put enough 6's there that shows me where I can move my decimal 2 places to the right. So I know that'll be my repeating number. So I'm going to end up with 66.6 repeating percent. Any questions on that? Percent decrease, original minus new divided by original. Percent increase, new minus original divided by original. Okay. All righty. So let's take a look. Oh, no. Homework. Let's go ahead and work through scientific notation together. Okay. Remind me what my first number is called. What is this part that comes before the times 10 to the power? Anybody remember what that's called? It's called the mantissa. And what numbers does that have to be between?
1 and 10.
Between 1 and 10. Okay, it can be 1 or greater, but it has to be less than 10. It can't be 10, it has to be less than 10. So 9 point something. Okay, so greater or 1 or greater, but less than 10. And then what does my exponent tell me? If it's positive, which direction am I going to move my decimal? To the right. If it's negative, which way does my decimal move? To the left. Good. So if I've got 3.14 and I'm moving my decimal to the right, I've got to go 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I fill in with 1, 2, 3, 4, 5, 6, 7 zeros. So I'm going to have 3, bless you, 1, 4, and then 7 zeros. 1, 2, 3, 4, 5, 6, 7. Now I'm going to look at commas. And remember, I start at the left and I count, I start at the right and I count to the left 3 and put a comma. So starting at the end, I go 1, 2, 3 to the left, comma, 1, 2, 3, comma, 1, 2, 3, comma. 2.007 times 10 to the 8. I'm going to move 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. My decimal goes there. I fill in with 1, 2, 3, 4, 5 zeros. So I'm going to say 2007 and then 1, 2, 3, 4, 5 zeros. Looking at doing my commas, start at the right hand side and count to the left 3. 1, 2, 3, comma, 1, 2, 3, comma. All right, now we have a -7 as our exponent. So we just said that that means I move 7 places to the left. So I'm going to start here and go 1, 2, 3, 4, 5, 6, 7 places to the left. Fill in with zeros. And I have 1, 2, 3, 4, 5, 6 zeros. So I have decimal 1, 2, 3, 4, 5, 6, 9, 2, 4, 7. We don't worry with commas in our decimal. All right, 6.0201 times 10 to the negative 6. I move it 6 places to the left. 1, 2, 3, 4, 5, 6. My decimal ends there. Fill in with zeros, and I've got 1, 2, 3, 4, 5 zeros. So I'll have decimal 1, 2, 3, 4, 5, and then 6, 0, 2, 0, 1. Now, going from standard form to scientific notation. So the first thing I've got to do is I've got to look at what I could do to make a number that is 1 or greater but less than 10. So remember, I look at my non-zero digits. So where can I put my decimal in the first one to make a number that is 1 or greater but less than 10? Between 1 and 2. Okay, so I know that's where my decimal needs to land. Right now, it is at the very end of my problem, okay, or at the end of my number. So I'm going to look and see how many places to the left I'm having to move to get to that decimal. So I'm going to start at the end and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. Okay, so I moved it 11 places, so I've got 1.254 is my mantissa times 10 to the 11th. We're going to do the same thing for the next one. Where can I place my decimal to make a number between 1 and 10? After the 2, before the 1. Good. My decimal starts out at the end of my problem, so I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the left. So I have 2.1030. Whoop, not 1030, just 103. 2.103 times 10 to the 10th place. Now remember, positive exponents imply that I have a large number. So now on the next one, I've got a decimal with a whole bunch of zeros, so I know that I'm going to end up with a negative exponent. Where can I put my decimal to change this one to scientific notation? After the 3 and before that 0. So I start with where my decimal is, and I move it 1, 2, 3, 4, 5, 6, 7, 8 places to the right. So that means I'm going to have 3.07 times 10 to the negative 8. Tiny numbers, negative exponents. And look at the last one. Where can I put my decimal to make a number between 1 and 10? Between the 2 9s. I start at where my decimal is, 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I have 9.9037 times 10 to the negative 9th place. Okay. So now for the rest of our homework, I want us to finish this page. Activities 4, 5, and 6. Let's look at each of these. Activities 4. What am I going to have to do first in each of these in activities 4?
Multiply by the denominator.
Okay, so to clear the denominator, I've got to multiply that by the denominator. Okay. To eliminate fraction, multiply by the denominator. Now, I will tell you on the last one, distribute first then clear fraction. Okay, so you're going to distribute your 3 first. Then once you've distributed, then clear your fraction. Activity 5 is just multiplying decimals. I am totally fine. Go ahead and use a calculator. I want y'all practicing some calculator skills. So use calculator. Okay, I want you to practice a little bit with that. All right, activities 5, add or subtract as indicated. When I add or subtract fractions, what must I have? What do I have to be able to add or subtract fractions?
Common denominator.
Common denominators, okay? Yeah, if you want to change, you can change them to improper fractions, yes, but you must have common denominators, okay? So let's look at 9 and 12. What could we use as our common denominators here? Remember, this is where I do least common multiple. So what I'm going to do is I'm going to think of multiples of 9 that are also multiples of 12. So 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. Will 12 also go into 36? Yep.
Yep.
So I'm going to go ahead and put CD for common denominator is 36. What about 7 and 3? What's my common denominator going to be here? 21. Good. What's my common denominator going to be for 4 and 12? 12. Good. We can use one of our numbers that we already have. What about 3 and 5? 15. Good. So use your common denominators. Okay. Remember, if you're adding, you don't necessarily have to change to improper fractions, but you would have to if you end up with a fraction that is improper, you'll need to convert it to a whole number and add it to your whole number that you already have. So you can either go ahead and change them all to improper fractions, add, and then simplify to a mixed number. But with subtraction, you will need to do improper fractions. Okay, so let's take a look at what our homework is. So we have got page 114, activities 3, those middle 2 problems. Okay, using order of operations, clearing fractions. And then on page 116, activities 4, 5, and 6. Okay. Any questions before we get ready and go? All righty. So we've got just a little bit left in this section. We have calculating markup. We're going to do some with simple interest and commission and things like that. And so I'm going to have on Thursday, we'll have a packet to put together to work on this section. Probably what we'll do, since so next week we're off for Thanksgiving. Okay, so can't leave that. Next week we're off for Thanksgiving. The week after that we are virtual. Okay, so we have Thanksgiving, we have virtual week, and then we have in-class week. And that is the last week before Christmas. We get out for Christmas. Okay, so basically we have 2 more weeks of class before we get out for Christmas break. So probably what I'm going to do is make your packet that I give you, that will count as a test grade. Okay, instead of trying to give you a packet to work through and give you a test. So on Thursday, I'll go ahead and give you those packets. So we'll have those to go ahead and start on, and then it will just be due right before we get out for Christmas. Okay, so that means take your time. It will not come back to you for corrections. So you'll want to make sure that you do everything, take your time, check it, all that good stuff. Okay. All righty. So you know what your homework is for Thursday. I hope y'all have a good afternoon. If you have questions between now and Thursday, please let me know. If we ever need to set up a Zoom time or whatever, let me know. Y'all know that y'all can always ask me questions during lunchtime as well. I'm in here on Thursdays before class. So anyway, all right. Well, I hope you guys have a great afternoon, and I will see you on Thursday. All right. Bye-bye.
Bye.